Hey guys, it's Vince. Today in this video we're going to be discussing a topic that I have yet to see discussed on robotic automation dealing with CNC robotics for production, and that is developing your own maintenance schedule for your robot. A lot of guys think that developing an automated machine is going to be their largest task, and it really isn't. Usually what you'll find is the maintenance of that robot to keep its critical points of accuracy, to keep its critical points of stability and production over time with consistency is going to be one of the trickiest tasks that you're looking to do, especially as a business owner, because we are looking to always drop our investment in replacement components over duration of the life of the robot. Now, in order to do this, and I've stated this in many previous videos, but I haven't really gone into explicit detail on developing a schedule and really developing what's to be looked at on a proper maintenance schedule, is you want to execute these details with extreme precision, and again, a very detailed person is required. That's why robotics, I feel, is so different in the sense that many guys will say, well, I own the same Avid CNC as another guy, and yet the two machines produce totally different parts when in both of the end user's hands, yet they're using the same machine. Now, in theory, with all the variables we know, that shouldn't be. But why is that? It's usually because something one end user is doing, another end user is not. Or perhaps how that robot is set, or perhaps how the calibration of the robot is set. We can go down the rabbit hole any way we like. But a huge variable, seldom discussed, is end users' level of detail when working with robotics. So let's look at an article I found here. It was one of the rare few I found online dealing CNC router maintenance. Now, why I picked routers is because most of you guys are using routers. For you guys using mills, again, same principle. Guys using plasmas, same principle. Most of you are not using Haas full commercial size scale mills, 5-axis machines. We're not really in that level. So again, dealing with more civilian-based equipment, this is where our primary area is going to be focused. So that being said, let's just start with their list, and I'm going to just kind of more or less abbreviate what they have, because not every detail they have will pertain to your machine, but certain other areas will. I'm going to cover some interesting points, so stay tuned. Maintenance schedules tend to vary with the machine, but there are 5 guidelines that apply to all of them. And I love this because the first one says cleanliness. I cannot emphasize enough, in all of the companies I've worked for, and again, Fortune 500 companies have a different level of attention to cleanliness and detail when it comes to automated robotics. Why that is because of the costs associated with them. If more end users, and I'll state it this way, I guess this is the best way to say it, pretended that they were a Fortune 500 or had the ability to say they've worked for a Fortune 500 and could implement the same procedures that these companies do, mimicking them, once again, not recreating the wheel, but just going with what already exists and implementing it to their small-scale machine, they would be virtually indestructible in sense of downtime, except for things that are out of their control. Okay? The issue is that most guys, when it comes to cleanliness and level of details I'm about to discuss, they do not go over their machine as meticulously as they should, and therefore some of the problems stay hidden until, of course, it costs them money. So cleanliness, without a doubt, it says here that it does not take long for a machine to get quite dirty. Most of them operate in what can be considered a very dusty environment, which accumulates the need for cleanliness. Buildups or fluids or chips can easily get into the bearings and controls. A sure recipe for problems if not corrected every day. Manufacturers generally recommend hand sweeping of the machine. An air gun can also be used to keep substances away from the bearings. Another fairly common recommendation, lower the air pressure during the cleaning process. Again, we don't really have to go into too much detail in terms of, do we have to, hand brush the machine? Do we have to use compressed air? I prefer compressed air. Most shops will have access to a large compressor that can be used for that. You can even use a small pancake compressor if your machine is a desktop size machine. Once again, the scale of the machine will dictate the equipment required to support it. This is the beauty of CNC where we are today. That wasn't always the case. If all you guys are working with, giant scale Haas's, that's not where you're at. You would need, commercial equipment to support it. But in what we're doing, the beauty of this whole process is that we develop a process for your machine and for the scale you're in. Okay? I highly recommend looking and going over the machine as slow as possible when you're cleaning it. Now, I want you to think about why I said that. The slower you go over that machine when you're cleaning it, the more you're going to see details you will overlook if you feel pressured in sense of production, or you're waiting to the last minute to produce parts for clients. I've seen that done. Again, you want to develop a process. This is something that a lot of you may or may not be familiar with, but a process is going to keep you out of trouble in the long run if you follow it consistently. Again, I cannot emphasize that enough. It cannot be something that's done, one day at a time. It's not going to work like that. Every day, you should start this process. And cleanliness at the end of every shift, absolutely. My personal opinion, after I run my equipment, I clean it after every run. That's the way I feel. Some guys do not feel that way. I find that you start with and end with a clean machine, you will never, ever, ever have most problems. Most problems will be eliminated. But without a doubt, if we're dealing with different transmissions, especially with our equipment, where we're dealing with open type frames, many of them are not using closed ways, where we have covers over the ball screws and potentially covers over the rack and pinion gears, which are notorious for catching debris and scarf. You really want to be careful, because especially if you have a direct drive or gearing, any of that debris or particulate gets in there, and it's going to throw the whole machine off as far as calibration, number one. Number two, it's going to penetrate the bearings potentially, and over time, it will degrade the way the machine operates. And I have had more and more past clients tell me this, and it's kind of disheartening because, again, I would hope that whoever purchases and spends the amount of money it takes even currently to purchase, a proper robot for the application they're getting into with their business, that they would look at, hey, this is an investment. I want to take care of it to the best of my ability. That's not always the case, guys. And I'm just being honest. It's not. I've seen pictures. I can't logically answer what I'm looking at. When I see hay or, some other debris all over the motors, which makes no logical sense to me yet, it's being done, and I see it. And like many of you, you're wondering, if I just keep this machine clean, I should be out of harm's way for most issues. Or at least you'll find an issue before it becomes a bigger one. And I can't emphasize that enough. Now, one other point I want to make out that goes with cleanliness, and actually probably even before it, is the environment in which your machine is placed. I have certain clients that use a basement. I have certain clients that use their garage. I've seen machines in third and fourth bedrooms. I'm going to be completely honest with you. It's irrelevant where you place the machine in terms of whether it's indoor or outdoor. What is relevant and really affects the whole life of the system is whether or not it's in a climate-controlled environment. Now, if you're in Canada, you're going to be dealing with a lot more cold, per se, than Florida. Okay, I'm in Florida. If you're in Canada, you deal with a totally different climate region than we deal with. However, if you're in a climate-controlled environment, it's irrelevant. We're basically in both the same playing field. Okay, humidity and where I live and a lot of other areas of the states will destroy electronics and the actual robot itself very quickly, with surface rust and all kinds of other issues, if that robot is exposed over time. I have seen this constantly, and developing a maintenance schedule is really going to be affected by the environment in which the machine is. Because again, if we have a lot of humidity, the cleanliness even becomes more of an explicit detail, because again, we'll have moisture in the air at higher content, and you're going to find that any type of dust and whatnot will stick a lot more. And again, you really don't want to deal with surface rust if at all possible. And if you do encounter it, take care of it immediately. And I cannot emphasize that. I've seen guys where they're running, plasma systems, and their rail system is covered in surface rust. Guys, come on. I mean, we have to think about that. We have to look at that. That machine is making you money. It should be treated like gold. I mean, it is an investment, and it will definitely make up for you hiring someone else. Take care of the equipment. Change filters. If it sounds, it says here, if this sounds like an instruction found in an automobile manual, there's a reason for the similarity. Just as clogged filters jeopardize cars' engine efficiency, the same applies to the machine's control box and vacuum pumps. They too must be changed on a regular basis, as do pneumatic filters that trap oil and water in pneumatic lines. However, the frequency of filter changes depends on the type of materials being cut and other facility environmental factors such as dust and dirt, which is why there is no standardized schedule. It depends on the specific shop. As a rule of thumb, all filters should be checked weekly and changed as needed. Again, depending on what kind of machine you're running, not every guy has filters in their shop. Some guys do. This is logic. It makes sense. Check it weekly. Set a checklist up. I cannot emphasize that enough. Set it up one time in Microsoft Word or another format. You can handwrite it and just go over that checklist every day, and you will develop that pattern. Okay? Again, as a pilot, I can tell you we have pre-flight checklists. We go over those checklists because if you screw up in flight, it's life and death most of the time. I mean, you might get away with a couple instances where you're going to be okay, but no one wants to crash land at all, especially when you have your family or whatever. So think in terms of that. Keep in terms of what you're looking at and where you're going with this. Again, filters may or may not pertain to your specific robot, but in this case, they're discussing it and with good need. Lubrication. This is a question that comes up to me all the time. What do I recommend to lubricate your machines with? What kind of grease do I use? How often do I do it? This is going to really be dictated by what robot you're using. Now, every one of our robots use bearings. Bearings, some come in a full seal format. There are ball screws that are fully sealed. Some ball screws require maintenance. Some ball screws do not in terms of more routine. Usually you'll see that the manufacturer will say do it, after so many hours or a length of time. My recommendation is this. First, whoever you're buying the ball screws from or the robot from, don't be afraid to ask them, hey, what is your lubrication schedule? What do you use? Now, when I say what do you use, a lot of times you will find that a vendor may come back and tell you to use a generic lubricant like WD-40. I'm not a big fan of that, and I'm going to tell you why. Every lubricant on the market for industrial use is going to be designed differently for the application you're associating it with. Robots, we want to be careful on what greases we use, what lubricants we use, because we don't want to attract more dirt. If we attract more dirt, it's kind of counterproductive because you're going to be using more product and you're going to find that your actual robot's going to last a lot less or have a lot less longevity. So there's no benefit there. Most of the time I recommend graphite lubricants unless there are areas certain ball screws will require grease, in which case I would go to the manufacturer and say, what specific grease do I use? Do you know? Some may not know. I've had clients come back to me and tell me they've purchased ball screws from manufacturers, including Highwind, and they may not know a specific grease or give them a number that may not be available here, in which case you would look at what's the next best in line. But lubrication has to be done regularly. It says here again, this is an action step so basic that no reminders should be necessary, but reminders emphasize the importance. The nice thing about routers is that despite all their parts, they do not require extensive lubrication. But as with all machinery, breakdowns are inevitable if the process is not maintained as required. Making it worse for the ownership, should failure to lubricate to be determined as the cause of the malfunction, there is a possibility that the router's warranty will be voided. Now, I've never seen that, but just because I haven't seen it doesn't mean in the future or systems that are on the market currently I'm not familiar with, that may be the case. The last thing, any business in general, a chief financial officer in particular, needs to confront bearings, pumps, and oscillating knives need regular lubrication. But again, the regularity is dependent upon the type of machine, the extent and use in its environment. I just covered that. expect the schedule to vary. You shouldn't expect the schedule to vary. In my eyes, I would say lubrication should be done easily on our civilian-based machines every 10 hours. Every 10 hours of consistent use, and when I say lubrication, let's be real. You only use the machine 10 hours. If you're doing that and you're staying consistent with it, you can cover up lubrication very quickly. Does everything feel smooth? Is everything looking good? Okay, I'll just touch it. I'll just touch it with a little bit of this or a little bit of that. I'll hit the double check the ball screws. You don't have to re-grease ball screws naturally fully every 10 hours of use, but I would use that 10-hour window to go over your system in a manner that allows you to become familiar with it. Because as you become more intimate with the system, you're going to find problems rise a lot faster and are more visible. Okay, and I have guys say, well, how am I going to monitor all of the time associated with me actually running this preventative maintenance schedule? Come in the window, or excuse me, come into Mach 3. I've got it open right here under Operator tab, and I've done a video on this. These are features you may not know you have. Under Maintenance Hours, click it. And if you go in this, you can see total distance moved for all the axes that are associated. This session, there's a time, total opening or operating time, spindle on time hours. It shows you basically everything you need to know. Okay, so total operating time, and you can reset this after every set interval. So if we say 10 hours, you can reset this after you hit 10 hours, going over the machine, and boom. That way you know you're tracking everything. And again, this combined with the pad and pen, associating it with a proper process of maintenance, you guys are going to be set. Okay? So, I mean, this is something that's built into Mach 3. It wasn't put here by mistake. It's not discussed enough, and that's what costs most guys money. I'm being honest. They worry more about, how fast they're cutting, whoever's ordering today, but they're not looking at the detail level of the machine, and unfortunately it bites them in the end. Okay, so let's come back here. We got air supply cleaning. I'm just going to cover this briefly because most machines, unless you're dealing with much larger scale, are not really working with air supply. Most router's operate with pneumatic air that has to be clean, dry, and maintain a steady air pressure more than 80 psi at 6 barometric. Damage to the machine is likely in a very short time frame due to incorrect specifications, so pressure should be checked regularly. Again, time frame, small scale equipment. My recommendation is I would start with 10 hours. Safe and proper electrical power. Now this is interesting because again, when you look at this list, I'll have some guys say, well, this should come before this or that should become. It's really a sense of symmetry that all of these are extremely critical. All of these topics are extremely critical. Once again, the caveat for electrically powered machinery applies to the CNC router. The power must be sufficient and safely connected as required by local power regulations. Machine failure is likely to occur in cases of poor electrical grounding, low voltage, or insufficient capacity. As is the case with every computer operating mechanism, power spikes will cause serious damage. A guide for daily and weekly preventative maintenance inspection forms accompanies each router. Now again, it's not going to accompany a router you purchase naturally from China or from another vendor, potentially. I'm going to say this, now with as many vendors that are hitting the market, that's the first thing I would say. All these companies claiming to be professional and, hey, we're in this community and all this other crap, if they don't have a preventative maintenance schedule that comes with the machine, be wary. Because that means they've never thought of that. And do you want to buy a robot from a company who didn't even think of how to maintain it? That's frightening, guys. Frightening to me. So I'm just telling you, that's something I would definitely think about. And again, bring it up to them. If they don't have one, you could say, well, you guys might want to actually look into creating a form for that because for your end users, it's great to know. Okay? They're saying here again, inspection forms accompanies each router and includes times for logging operating hours. Now, I just showed you that inside of Mach 3. So you have that general cleaning, air pressure readings, oil for the oscillating knife, checking the pump oil, and cleaning the cover nut threads. Again, pending, of course, the router that you're looking at or mill has that. Monthly inspection forms including greasing racks, pinions, bearings, vacuum table, gasket repairs, if needed, and cleaning all filters. In addition, a form for biannual maintenance inspection lists replacements of all filters, vacuum performance testing and inspection, and tightening of all timing belts and transmission among its inspection checks. Now that's interesting because we covered tightening all timing belts and transmission among its inspection checks. Without a doubt, that 10-hour window that I've just discussed with you, that should without a doubt be covered easily in your transmission. Okay? Transmission is without a doubt going to be one of the areas of high concern, because if that tranny ever gives you trouble, whether you're using a belt drive, which requires the most maintenance, right down to a ball screw, which requires the least maintenance, you're going to find your accuracy is going to vary. I've seen it so many times, it's frightening. Guys will tell me, oh, the machine's working great one day, the next day it's not working great. They go over their belts, oh, I've done it, last month. Well, how many projects have you done since that previous month? Did you document everything and everything was good? Do you guys use torque measuring devices when you're actually tightening bolts to make sure everything is set to spec and you're not over tightening or potentially damaging anything? It sounds like I'm being extremely critical, and I am. But I also don't want to pay more than I have to maintain my robot. So think about what I'm telling you and think about what I'm implementing, because like I said, most vendors, and I'm not developing full chassis like many of them are selling, I'm just doing the controller. They should be supplying you this information. I've never seen it, and I feel that realistically, if they did supply it, yes, it would cut down you spending more on components from them, but you'd be a happier client for a much longer extended period of time. Again, go over the transmission. I would say a minimum of 10 hours. Go over that transmission carefully, especially your timing belt guys. Rack and pinion, definitely. Check your gear engagement. Make sure nothing has changed. You can use a couple sheets of paper just to go in between the gear to make sure your spacing is there, because that piece of paper will give you 3 to 4 thousandths clearance for proper gear engagement without binding. Check the binding ratio on each end of the chassis. This is something seldom looked at. There is very seldom times that you will find, I don't think I've ever found it personally, where the rack, where it engaged the actual motor or the transmission gearing, is completely symmetrical all the way throughout, and that's because the machining process is never exact. So again, keep that in mind and prepare for it. And the way you prepare for it is go over everything, make sure it's sound. Another key point is make sure every bolt on your chassis is either using a lock nut, which has a nylon gasket into it, which basically formulates a seal around the threads so it doesn't vibrate loose, or Loctite. And Loctite, I recommend the blue because it is removable, but these are not optional. This is mandatory, and it's seldom done. But it will guarantee that you won't have screws come loose and things just manually, come over time, lose their accuracy due to the fact that the fasteners are becoming looser. So these are things to really, really think about. Scrutinize your equipment, guys. The more you scrutinize it, I promise you're going to save a bundle of money, you're going to have a higher ROI, and you're going to find that over time, the robot, you're going to know so well, even the slightest sound. I have certain clients that can hear the cutting of, just a different substrate. The end mill's wearing at a certain pace, and they know something just doesn't sound right. I'm going to change this, and they know right away, boom, that's what it is. And that's where you want to be. You want to become scientific with it, where you know, hey, I'm the guru of this machine. That's all that matters. Okay? So again, going over this, we can see here what they're actually covering. They say here, Kovac attributes, adherence to maintenance for continuing performance reliability. And he's talking about, this is a gentleman who's talking about owning 3 routers, one of which is 12 years old. Kovac said the machines cut metal, wood, or metal work and plastics in an environment he describes as dusty due to the medium density fiberboard. Other fixtures and shades, since Barbican maintains its manufactured hardware, lenses and shades on site, he said router operations are rarely interrupted. We have had minimal downtime, and when we do, it's usually because of electrical parts that we've been trained to replace, Kovac said. Now, that's an interesting point. Now, he's saying this. Now, we're stepping into more my field, and I have guys that for some apparent reason do not service their machine's connections at all. They'll turn on the router or their mill and just go to town with it. And, maybe mechanically, let's say, hey, I've got the mill or the router all set, but they fail to go over the cables. They fail to go over the connections. Everything that's bringing life to that robot and making it a robot, they fail to analyze in a scientific manner that I just discussed. If you notice a screw is loose, if you notice that the connection isn't right, if you notice slight fraying or slight, more or less a peeling factor on your exterior casing on any motor cables, whether it be a spindle cable, whether it be a motor cable going to an axis, whether it be any leads going to your actual steppers or your servos, these are things to pay attention to. We don't brush it under the rug and say, well, I'll just do another run. And I've had guys do it. I just need to get through this run and I'm good. I'm going to make so much money and then I can buy this. First of all, let's think about that. Now, of course, I wanted this video to be short. Unfortunately, it's not going to be that short because I'm covering a lot of detail. But always have a backup supply of parts that are consumable. I cannot emphasize that enough. Once you've got the business model established, once you have all of your focus on your clients and the focus on the parts that you're producing and everything is going smooth, it's time to start building a backup of parts that you feel comfortable with so that you can mitigate downtime. I can't tell you how many guys that say, hey, Vin, I need you to overnight on Saturday parts when it's a stupid motor. He could have had it in stock, and for the price of Saturday delivery, he could have had 2 or 3 motors in stock. It's stupid. Think about what you're doing. Think about it. And it's funny because it's usually that guy's wife that says, hey, you should have just ordered it before. Yeah, you wouldn't have made as much on this previous job, but guess what? You wouldn't be paying $300 in shipping because if you don't produce this part, you're going to blow the client's deadline. Think about what I'm saying, guys. Think about what I'm saying. It doesn't make sense. Have an extra drive in stock. That's what makes the G540 a brilliant drive in that sense that they're cheap. You can have an extra drive in stock and be up and running in no time. Send the other drive out to warranty, you're good. You can't necessarily do that with Chinese drives, but if you are running Chinese drives, they're cheap enough as well. Have an extra one in stock if you're comfortable with that. Be realistic. Extra parts means mitigation of downtime. And when I say that, be real. You don't need a whole router in stock. You need the parts that are consumable. Cables are always going to be consumable because, again, they're under stress. They're in a cable chain and moving constantly. There's friction. We have to look at that. Bearings, those are consumable. Unfortunately, I wish I could give you more detail on what bearings will be required for you to keep in stock, but the thing to keep in mind is this. Your vendor, whoever you bought the machine from, they should be able to tell you, hey, you can ask the wear patterns, what do you consider parts that we should have in stock? Now, some of them may try to oversell you. I'm not going to lie. That's the industry. Be realistic. Bearings should last easily years if they're cleaned and everything is maintained as properly as we're discussing here. And, of course, you're formulating a process. But think about that. Think about what we're looking at here and think about the most commonly used parts, motors, cables, couplers. I have guys always tell me a coupler broke or something, I can't believe this happened. I see DB9 connectors that are completely fried. And they're like, oh, I don't know what's going on with this connector. I can't figure it out. They're like, well, I can't figure it out either because I'm not there with you. And I didn't create a maintenance program. So you have to deviate from the way of thinking you're previously done rather than getting the new part. And I've seen this too, guys, and it's more frustrating on my end because I'm sitting there thinking, if you're practicing the definition of insanity, which is simply buying a part, putting it back on the machine and thinking the problem is going to miraculously go away, it will temporarily. But the thing you have to keep in mind, if we don't analyze what's causing that problem and find the root cause, you are literally practicing the definition of insanity by doing the same actual process and expecting a different result. So think about what I'm telling you, okay? You can save a lot of money that way. And I'm telling you right now, the electronics is without a doubt an area that should always be looked at. When I say electronics, I don't just mean the controller. Look at your computers. Let me talk about that for a second. I have had in the last week alone, just this week, and this is no exaggeration, 3 clients tell me that they've had hard drives fail or their computer fail in general, which they never identify what actually failed, just a computer, and they had to reinstall everything and lost time, money, they lost files. I had one guy totally lose everything. That's ridiculous. A hard drive today, a solid state hard drive, you can buy a 128 gig hard drive for like $25. I mean, what are we doing? How much is your time worth? How much is the effort worth that you're working with? Think about that. You know, like I said, it's more frustrating for me because it's like, did that really happen? You know, I mean, how does one let that happen? Anybody in manufacturing, especially small scale, running a business, or even starting a business, or these AKA hobby users, or whatever they want to call themselves, the bottom line is this. No one wants to lose all their files. No one wants to lose the time and all of the money that's associated with going back and reinstalling this, buying a hard drive. Buy a hard drive, put it in your system, a backup drive, and create an auto backup file to where all of that stuff is saved. In the event something happens, you don't have a worry. You can be up and running again in a few minutes. And I've seen clients do it, and they usually come back, and if we've discussed it, they're like, "Man, you're right, you know, try it." I'm telling you right now, I've been in the industry long enough. I've seen nightmares, and you don't want to go through that, especially if you have a client, once again, expecting a deadline or you're trying to do products. This can be a tragedy. So avoid it. Finishing up, wrapping up, and I'm sorry again for going as long as I did, but again, this needs to be said. Going beyond the checklist. Shops using routers have learned that there are times where a checklist is not enough to ensure smooth operations. As mentioned above, the car is an apt metaphor, and I love that metaphor because I say it all the time. Much like vehicles, if the router does not sound just right, additional analysis is necessary, even if all checklist steps have been completed in a timely fashion. I get one-line emails most of the time that a guy says, "Hey, this is what's wrong with my machine. What do you think?" If I could just sit there and listen to someone say 5 words and I instantly know an answer, I mean, I wish I could. Unfortunately, that's not the case. Okay? With you asking me to diagnose your robot in a matter of 1 sentence, unless it's a yes or no answer specifically dealing with, you know, an explicit detail, let's say Mach 3, I might be able to do that. But if you're telling me you're having this intermittent problem with what you feel is EMI and it's been going on for 5 months and now you're having this and that, and I mean, there's no way I can do that. You're essentially asking me to be a mechanic and analyze a car without it in front of me. So my natural response is, let's set up a consultation. We can go over the job right remotely with Microsoft TeamViewer. You'll use your webcam. I'm basically virtually there with you. That is the only way I can see what's happening. Because, again, if you don't know what's going on and you're asking someone that potentially might, you're basically limiting my senses. So we have to look at that. And, again, I think it's time we really think about what we're talking about when you request support. And that doesn't just pertain to me. That pertains to anybody. Even whoever sold you the system, the more detail you provide that person or that company, you hopefully will get that amount of detail back. Think about it. Just, to me, it's logical. The emphasis on preventative maintenance should be the same at the end of the day as at the beginning. Users should have a cleaning procedure to make sure to remove every tool in the spindle. Totally agree with that. Shop owners should impress upon their workforce that shortcuts are counterproductive and ultimately costly. These machines have been designed for long-term use. But as is the case with all high-tech equipment, failure can occur when procedures are circumvented and long-range issues are inevitable. The possibility of failure can also occur due to other causes such as improper operational procedures, tools that break because the right setup has not been implemented, or the machine's movement is obstructed, which increases wear and tear and inevitably shortens the lifespan. The best way to ensure lengthy and productive router operations is to follow the manufacturer's maintenance recommendations so that owners reap the full benefits of the machine's capabilities. Now, again, I'm going to reinstate what I said earlier. 98% of our robots, meaning routers, mills, plasmas in general, do not come with a maintenance schedule. I have not seen them. I have not heard anyone discuss it. I would love to see it. I think it would really be more beneficial to you, but that's okay even if they don't. Develop your own, guys. Most of you are building your own system, at least the guys that usually work with me, or are retrofitting a system. You should be intimate with the machine. Go over it, and once again, set your parameters at around that 10-hour service mark. It's going to take time initially to go over the machine. As you build momentum doing it, and I've stated this earlier, it's going to get much easier. Why? Because you become more familiar with the process. It's like everything else. You become more efficient, and it just takes time, and you're going to become super efficient at finding what is wrong with the machine, and that's just immeasurable. No more guessing. You'll be like, hey, it's this. It's definitely this bearing. It's definitely this motor. Something here does not sound right. The best way to ensure lengthy and productive route operation is to follow the manufacturer's maintenance recommendations so that owners reap the full benefits of the machine's capabilities. Consider other service packages offered by the manufacturer, since all machines, regardless of their sophistication, will experience wear and tear no matter how thoroughly the plan is followed. And that's true, guys. I don't know about taking out an extended warranty, if that's even worth it, but again, if you're getting involved in this genre and you're using a robot, the byproduct of anything mechanical is over time parts will fail. Once again, that's not always a big deal if you prepared for it. If you haven't prepared for it, it's a kick in the nuggets. So think about what I'm telling you, and again, be prepared. Prepare for the worst, hope for the best. The old military model always works. Again here, regardless, and if the machine is idled, the calls will be determined to be maintenance shortcuts not recommended by the manufacturer. The company is left with an expensive, non-functioning piece of equipment and a drain on its balance sheet. And I've said that before as well, guys. Any machine that has any issue with computer, motors, ball screws, you name it, cabling, you have so many variables on these robots, from the cooling system down to, screws, anything. If anything is not in harmony, you have a paperweight. And that's the unfortunate side of the industry we're in. It'll do amazing things, but it's only going to do those amazing things consistently with accuracy if end users follow a proper maintenance schedule implemented over time, and that major word, consistency. So again, I hope that this video has been helpful. I'm going to end it here because I think we've covered enough. Hopefully you guys have got it down. I'm going to say it again. Set your maintenance interval going into Mach 3 or whatever motion control software you're using, whether you're using Pneumatics, Mach 3. Linux, I'm not sure if they have one. But again, maintenance hours, you can do this any way you'd like. Set it at 10 hours at least initially, and you can tweak it upon that. But I always say this, the better you get, the faster the process becomes. And you will find that over time, this entire process should be streamlined very quickly, and you'll be in and out, and then you'll be able to fine-tune it. But I'd say 10 hours is a sweet spot, especially for civilian-based equipment. As time gets better, you might go to 15. I would never go past 20. That's my own personal opinion. I do 10 hours. I feel comfortable with that. Usually, honestly, I go maybe 8. That's me. Everybody's different. My recommendation is start with that initial 10-hour increment and see how everything is holding up. And by that time, you should be able to develop, once again, your own process. And hopefully for that one guy who's probably watched this video to the end, he's going to see and reap the benefits of a lot less investment overall and a lot more longevity in that robot making him money.